All right, so turn my desktop audio up. All right, let me going over I guess module 10 to whichever one I fucking stop at. It'll probably be in the video's title. So let's fucking close this. All right, so okay, configuring your compiler extensions. The C++ standard defines the rules about how programs should behave in specific circumstances. And in most cases, compilers will follow these rules. However, many compilers implement their own changes to the language, often to enhance compatibility with other versions of the language. For example, C99, or for historical reasons, these compiler-specific behaviors are called compiler extensions. Writing a program that makes use of a compiler extension allows you to write programs that are incompatible with the C++ standard. Programs using non-standard extensions generally will not compile in other compilers that will support these same extensions. Or if they do, they may not run correctly. Frustratingly, compiler extensions are often enabled by default. This is particularly damaging for new learners who may think some behavior that works as part of official C++ standard, when in fact their compiler is simply overpermissive. Because compiler extensions are never necessary and cause your programs to be non-compliant with C++ standards, I recommend turning compiler extensions off. Disable compiler extensions to ensure your programming and coding practices remain compliant with C++ standards and work on all systems. So, go to the project, then the solutions. From the project dialog, first make sure the configuration field is set to all configurations. Then click C language tab and set conformance mode to yes, if not set there by default. All right, so let's go. What was I working on? Project 3 last time I was on here. Oh, well, this is not. I think I was doing. Yeah, Project 4 was the one I had open. So we're just gonna go here. So you want to go to your project, properties, make sure configurations is on all. I think they said they want to go to. I don't remember where they went. Where did they even go to? Yeah, they went to language. And then turn this to. Yeah, so you just want to make conformance mode to yes for all your projects. Basically, what they're saying. That's standard practice. For GC users, go. I don't care about none of this. Reload content. Execute users can refer to. Okay, a reminder. These settings are applied on a per project basis. You set that every time you create a new project, or create a template project with those settings once and use that to create new projects. Okay, template projects, by the way, are just if I were to make a new project, you search for templates so you can make your own template. So warning and error levels. When you write your programs, the compiler will check to ensure you follow the rules of C++ language. Assuming you've turned off compiler extensions as per lesson 10, if you have done that, if you have done something that definitely violates the rules of the language, the compiler is required to emit a diagnostic message, often called a diagnostic for short. The C++ standard does not define how diagnostic messages should be categorized or worded. However, there are some common conventions that compilers have adopted. If compilation cannot continue due to the violation, then the compiler will emit an error, providing both the line number containing the error and some text about what was expected versus what was found. Errors stop the compilation from proceeding. The actual error may be on that line or in a preceding line. Once you've identified and fixed the erroneous lines of code, you can try compiling again. If compilation can continue despite the violation, the compiler may decide to emit either an error or a warning. Warnings are similar to errors, but they do not halt compilation. In some cases, the compiler may identify code that does not violate the rules of language, but that it believes could be incorrect. In such cases, the compiler may decide to emit a warning as a notice to the programmer that something seems amiss. Best practice, don't let warnings pile up. Resolve them as you encounter them as if they were errors. Otherwise, a warning about a serious issue may be lost among warnings about non-serious issues. In most cases, warnings can be resolved by either fixing the issue that the warning is popping out, or by rewriting a line of code generating the warning in such a way that the warning is no longer generated. In rare cases, it may be necessary to explicitly tell the compiler to not generate a particular warning for the line of code in question. C++ does not support an official way to do this, but many individual compilers, Visual Studio and GCC offer solutions via non-portable Hashtag progma directives to temporarily disable warnings. Increasing your warning levels. By default, most compilers will only generate warnings about the most obvious issues. And you can request your compiler to be more assertive about providing warnings for things they find strange. Turn your warning levels up, especially when you're learning. The additional diagnostic information may help in identifying programming mistakes and cause your program to malfunction. So just go to projects. I think we were just on it a second ago. Yeah, warning level. And you can change this. Say enable all warnings. Okay. So now when we're coding, we're gonna enable all warnings. So if anything is not per the standard, then we'll change it. Or we'll buried in warnings. Okay. Well, let me actually. Yeah, it's pretty embarrassing. Let me change this back to level 4, I guess, because all warnings is too loud. Functions enable all warnings, or you'll be buried in warnings. Disables signed / unsigned convention warnings by default, and those are useful. So if you're using Visual Studio 2019 or newer, let's enable those. From C to C++, command line tab under additional options, add /W44365. It tells the compiler to enable signed / unsigned conversion warnings at warning level 4, which you enabled above. From C to C++. Okay, let's go here. So command line tab under additional options. So command line tab. Yeah, so let's just go in here. Additional options, add this, press OK. Yeah. Okay. From C to C++, external includes tab, set external header warning level to level 3. So, okay, let's go here. What did they say again? They said external includes tab. Is that, where is this? Set external header warning level to 3. From C to C++. Oh, okay, am I retarded? It's literally right in front of my fucking face. Okay. External header warning level to level 3. External header warning level 3. External includes tab isn't shown in the graphic above, but appears in VS Community 2019 or newer between the browse information and advanced tabs. See this link in the recent photo. Okay, if the above has been set correctly, compiling the following program should generate warning. So let's just function fig mid-stack. Okay, respect. So generate the following warning: C4365. Okay. Now see this warning. Check both the output and error tabs. Okay. Okay, treat warnings as errors. It is possible to tell your compiler to treat all warnings as if they are errors, in which case compiler will halt compilation. Finds any warnings is a good way to enforce the recommendation that you should fix all warnings. If you lack self-discipline, which most of us do. Enable treat warnings as errors will force you to resolve all issues causing warnings. Okay, this is a project dialog. General, okay. So general. Treat warnings as errors, yes. So it's an unsigned int x5, foo of x, and there's nothing inside of foo. Following warning shows an error. What's our warning here? Array conversion from unsigned int to int. Okay, well let's just make this unsigned real quick. Oh my god, it worked. Function foo can be static. I appreciate that. Okay, cool. Alright. There we go. No warnings or errors. Let's get it. Okay. For Visual Code, you use a test.json file, add the following flags before the file, one per line. What was talking about? Oh yeah, it doesn't matter. Okay, configuring your compiler, choosing a language standard. With many different versions of C++ available, C++ 98, C++ 03. Okay, who gives a fuck? How does your compiler know which one to use? Generally, a compiler will pick a standard to default to. Typically, the default is not the most recent language standard. Many default to C++ 14, which is missing many of the latest and greatest features. If you wish to use a different language standard, and you probably will, you have to configure your IDE of such compiler to do so. Original names for language standards, e.g. C++ 20, are based on the year the language standard was published, expected to be published. Because the year publication is not already known until it is close, language standards that are early in development sometimes use a development name instead. For example, C++ 20 is also known as C++ 2a. Okay, as an aside, C++ 11 has developed the name C++ 0x because it was originally expected to be published before 2010. Which language standard should you choose? In professional environments, it's common to choose a language standard that is one or two versions back from the latest finalized standard. For example, if C++ 20 were the latest finalized version, that means C++ 14 or C++ 17. This is typically done to ensure the compiler makers have had a chance to resolve defects, set as best practices for new features. So that best practices for new features are well understood or relevant. And this also helps ensure better cross-platform compatibility, as compilers on some platforms may not provide full support for newer language standards immediately. For personal products and while learning, we recommend choosing the latest finalized standard, as there is a little downside to doing so. Tip: many compilers offer experimental or preview support for features from the upcoming non-finalized language standards. Your IDE may offer this as an option in the settings where you configure a language standard, or you may be able to enable it manually using the upcoming language standard's conventional name or development name. Support for features from non-finalized language standards will be incomplete and possibly buggy. I'm not going to worry about this. A reminder: when changing language standard or any of the product settings, make the change to all builder configurations. Setting a language standard in Visual Studio. As for the time of writing, Visual Studio 2022 defaults to C++ 14 capabilities, which does not allow for user of new features introduced in C++ 17 and C++ 20. To use these newer features, you'll need to enable a newer language standard. Unfortunately, there is currently no way to do this globally. You must do so on a project-by-project basis. Visual Studio, you will need to reselect your language standard every time you create a project. Yeah, okay, this is pretty easy. You just go to projects, properties, general, right here. I usually set mine to 20. I mean, y'all can set yours to whatever y'all want. First, make sure the configurator is set to all configurations. You may set the language standard, which is the latest standard, which will ensure you have those many features compile supports. Make sure you're selecting the language standard from the drop-down menu. Don't type it out. More information on Visual Studio settings. Okay. What language standard is my compiler currently using? So we move to the next lesson. What are your configuration? Having to reselect all of your settings options every time you create a product is burdensome. Fortunately, most IDEs provide a way to export your settings. This is typically done by creating a new product template with the settings you want, and then selecting that product template when you create a new product. Where can I view the C++ standards documents? Okay, let's just do that real quick. New. How do you even create your own template? I honestly have no idea how to even create my own template, if I'm being straight up with you. Okay, let's just finish. Where can I view the C++ standards documents? Each C++ standard is described by a standards document, which is a formal technical document that is the authoritative source for the rules and requirements of a given C++ language standard. The standards documents is not designed for learning, rather it's designed for compiler writers to be able to implement new language standards accordingly. You'll occasionally see people quoting the standards document and explaining how something works. The approved C++ standards document for a given language standard is not available for free. Here's a link to purchase the latest standard here. When a new language standard is being developed, draft standard documents are published for review. These drafts are available online for free. The last draft standard before the approved standard is generally close enough to be the official standard to use for most purposes. You can find the standard drafts here. I love this, so I'm not going to bother looking at that if I can't look at it. Compilers often have incomplete support for new language features. Even after a language standard is finalized, compilers supporting that language standard often still have a missing, partial, or buggy support for certain features. If you attempt to compile a program that should compile but mysteriously won't, it's likely because of one of two reasons. Your compiler is configured to use an older language standard that doesn't support the feature you're missing or using. Try selecting a newer language standard and compile your program again. You can use the program lesson 0.13 to validate that you have configured your language standard selection correctly. The version of the compiler you're running may have missing, partial, or buggy support for a feature you're using. The C++ reference website tracks compiler support. Okay, if a new version of your compiler supports the problematic feature, you can upgrade your compiler to the latest version and try compiling your program again. When this version compiler still doesn't support the feature you're trying to use, you can either try using a different compiler that does provide support, or find a different solution. Okay, let's look how to create your own project template on Visual Studio. Okay, this article shows how to create a template by using the export template wizard, which packages your template into a zip. Create a project. Use only valid identifier characters. Edit the project till it's ready to be exported as a template. For example, you might want to edit code files. Project menu. So, project menu, properties. If you don't see the export template menu item, you can edit by choosing tools, customize, and select commands. So, export menu. Where is this at? If you don't see the export template menu item, you can just by adding tools, customize, manifest tool. What is this thing talking about, bro? Custom build setup. Yeah, I don't see anything this thing is talking about, to be honest with you. Like, it says something, and then it says on the product menu, choose export template. Is this here? Like, unload project, hide dependencies, open terminal properties. Set a startup project. Am I retarded or something, or does it just not here? Oh, is it up here? Oh my god, there it is. Okay, project template name, the default console. Just make it. Okay. Alright, so if we just let's do new project, we can use default console. Oh, okay. Respect. I did not know you could do that. I mean, I knew you could do it, but I've never done it myself, so I guess that's good to learn. Anyways, this will be it for this video. What do we make it to? 0.13. We start off at 0.10, I think. So I'll just do, yeah, I do 0.10 and 0.12. These are the ones we did. Alright, anyways, thank you for watching. I'll upload a new video. I don't know. We'll see. Whenever I get a comment or something, and I'll do it, I guess. I don't know.